Zero. Okay, so tell me if you can see my screen now.
Yes, sir.
So this was the one we were working on.
Yes, sir.
But connection threw me out. Or was it no? Before the battery went out on this device, and I now have to switch to the other one. But now I just figured that I think that one too. The battery was kind of low, so I said I'll just finish it as soon as they got the I have power. That was how we left off that day. Okay, but you can see in a question of simplify, technically nobody's asking you to solve for x. All you need to do is to just make it look as simple as possible, and that involves it being the task to practice. Okay, so you guys are doing functions now, right?
Yes, sir.
So I don't know if people have done the concept of remainder. They'll tell you something that is a factor of another thing. This one is like a linear function that is a factor of a non-linear function. And then they now ask you this kind of thing. Use this information to find the three solutions for the following equation. X. So, okay. So when they say something is a factor of another thing, it means the remainder, right? The remainder after division is zero, isn't it?
Yes, sir.
Hmm. Hmm. That's the implication. So, if we can find, um, yeah, if we can find a way to break this guy down, then we're able to solve, um, we'll be able to solve this particular this thing that they're giving us, like the root, to find the root of this um, graph. This graph that says 4x cubed minus 12x squared minus 7x. Okay, so the first thing we're going to do is, since we're told that this is a factor of this, right, obviously means that if we divide 2x plus 3 into, we divide this 4x cubed minus 12x squared minus 7x plus 30 by 2x plus 3, that division should give us the other thing that 2x plus 3 multiplied by that thing will give you the full function. So the way we solve this is long division. Um, I hope this is more like a reminder kind of thing, but well, I'm not sure. But if it's not, I'll do my best to explain it as much as I can. Okay, so let me. Okay, so there we go. 2x plus 3 Four x, um, minus 12x squared. Um, minus 7x plus 30. Okay, okay. So let's see how this goes, right? Want to find out what multiplies it. So when we're doing this kind of thing, we'll start with the first one, the 2x and the 4x cubed, and then we'll work our way gradually through the other one. So let's look at this now. 2x squared in 4x cubed is going to be uh, 2x squared, right?
Yes, sir.
Okay. Now 2x squared times 2x will give you 4x,
4x squared. No, 4x
huh?
cubed. 4x cubed.
And then don't forget 2x squared times 3 will give you plus 6x squared, right?
Yes, sir.
Plus 6x squared. Uh, okay, so we now find the difference. Of course, this one will 4x cubed minus 4x. Now, you have to be careful with the sign here. Minus 12x squared minus 6x squared is going to be minus 18x squared, right?
Yes, sir.
Okay. Minus 18x squared. Okay. So you know how we do long division? We bring down the next one after it is minus 7. Okay. So we are going to go again. 2x into minus 18x squared is going to be minus 9x, right?
Yes, sir.
Okay. Now, minus 9x times 2x, of course, you can see it's going to give you back the same thing there, minus 18x squared. Now, um, minus 9x times 3 times plus 3 will be minus 27x. Okay? Then we'll now subtract again. Now, minus 18 minus minus 18 as x squared is as good as minus 18 plus 18, isn't it?
Yes, sir.
That one is wrong. Now, let's take a look at this one that is with a lot of minus 6. Minus 7x minus minus 27 is as good as minus 7x plus 27. What would that give you?
Minus 7 minus that's minus 34.
Are you sure?
What did you say? You said minus 7x.
Minus 7x minus minus 27x.
Oh, that's plus 20x. Oh my. Wait,
Okay.
sorry. Yeah, that's plus 20x.
Okay. All right. So now again we go. Can bring down the set because that's the last thing there to be brought down. Mm-hmm. So 2x into 20x is 10, right? You get that?
Yes, sir.
Okay. So the same thing we did with all of them, we'll do again with the 10. 10 times 2x is what?
20x. 20x.
20. Mm-hmm. And 10 times 3 is what?
It's
So when you get to this point, you know that you did something correctly. Why? Because by the time you minus, you see that everything is identical. The remainder is what? 0. So indeed, this 2x plus 3, right? Hmm, what is a factor of what? Um, that's this 4x cubed minus 12x minus 7x plus 30. The only thing is now is that we did not know the other number. You know, when you say something is a factor of another thing, that means that that thing times another number will give you the original multiple. Okay. So in your mind, you can play with numbers like 2 is a factor of 6. So 2 times something will give you 6, right? 2 times 3 will give you 6. So we do not know what that second number was. But now we have found it out. And that second number was is what? 2x squared minus 9x plus 10. So in other words, look at how we can write this thing down. 4x cubed, uh, let me see how I can do this quickly. 4x cubed minus 12x squared and minus 7x um, plus 30 is equal to 2x plus 3. And put the 2x plus 3 in parentheses. So you're going to say multiplied by 2x squared 2x squared minus 9x plus 10. Okay. Now, you remember what the question said, right? The question said we should use what we know about this question and find the three solutions to the following equation. So the solution to a graph is where that graph is equal to 0. That means where this is equal to what? 0 is also where all this is equal to what? 0. So the first thing that we'll now conclude is that this implies that the first solution will be what? 2x plus 3 equals what? 0. You know how quadratic equations are. Sorry. Yeah, when you're solving quadratic equations and you have two brackets and they say the product of those two brackets equals 0, then that means one of the brackets equals 0 or the other one equals 0. So let's start with this one. Um, 2x, okay, let me just write it so that we have an understanding and not think that we're done already. So we're still coming for this guy, 2x squared minus 9x plus 10 equals 0. Okay? Alright, so let's work on the left hand side because that one is more straightforward. So 2x plus 3 equals 0 means that 2x equals what? Minus 3. 2x will be equal to minus 3. And therefore x will be equal to what? Minus 3 over 2. Okay. Alright. So for this right hand side, you can see that it's a full quadratic equation. So what are the options? When you have a quadratic equation like this, you remember those quadratic equations where I told you that when you check the coefficient of x squared, right, if it is 1, then you are free to ask yourself, what are two numbers? When I multiply them, they will give me this, and when I add them, they will give me this. Do you remember?
Mm.
Uh-huh. But we cannot do that with this one. You know why? Because of this 2. This 2 that is in front of x squared. This coefficient is 2. So instead of saying um uh, uh, just uh, asking ourselves those questions, the first thing we'll do is to multiply this by this, the first term by the third term, before we ask ourselves those questions. We have to multiply them together first. So this is the question you will now be asking yourself. What are two numbers such that when I multiply them, I will get 20x squared? So let's think about that. And if it's not possible, then we will now have to switch to almighty formula. And when we add them, will give us minus 9. Minus 9n. So can you think of two numbers such that when you multiply them, you get 20. And when you add them, you get uh, minus 9.
Mm.
So we usually start with the multiplication part. So let's work with that multiplication part. What are the things will give you 20 when you multiply them straight up? 4 times 5, right? In
Yes,
fact, you
sir.
can even start with 10 times 2 or 20 times 1. All these are possibilities. But which one will actually give us minus 9?
Mm. Minus 5 times 4. Um, times plus 4.
Minus 9,
Minus
minus 5.
5.
Eh? So
Or,
minus 5 times plus 4 will not give me plus 20. It will give me minus 20.
okay, that's minus 5 minus 4.
Thank you very much. Got it. So, you got it. So the two numbers are minus 5 x. I don't know whether you notice the slight difference in this method from the one that we know when the coefficient of x squared is 1. The slight difference is just this. Multiply the first term by the third term before you start asking the question. But once you've done the multiplication, you can see to ask the question. Only that you are not just using 10 for the multiplication part. but the addition part is still the middle one. Okay. The only difference is that multiplication part, which is gotten by multiplying the first term by the first term. Okay, so let's go. So now we can rewrite our quadratic equation to become 2x squared minus 5x minus 4. All we just did was to replace the minus 9. Since minus 5 and minus 4 will give us minus 9 too. We'll still write the other ones exactly as they are with their signs and everything. And don't forget to put your equals to 0. So you can guess what I want to do next. I'll factorize by grouping, isn't it?
Yes, sir.
So what are the things that are common between 2x squared and minus 5x?
2. Is
What's
it
common?
2?
Are you sure about that? Now you have 2 and you have 5.
Okay.
5 is an odd number. 2 is an even number.
Yeah,
You I
it,
don't think anything can work there, right?
yeah, it can't.
So let's just pick the x. You understand, Abby?
Okay, I understand what you mean now.
Uh, Minus 5. Okay. And when you are doing this, you have to make sure that the second bracket looks exactly like this first one. So what is common between minus 4x and plus 10?
Mm, minus 4x plus 10. 2.
Yeah, but not just 2. Instead,
2.
minus 2. No one.
Okay.
If you don't pick minus 2, you know what will happen. You see this plus, the plus will stay like that. And there will be a difference between the second bracket and the first one. So pick minus 2 so that when you say minus 2 is common, then it will now leave 2 inside the bracket, which is exactly like the first bracket. And then from plus 10, if you divide plus 10 by minus 2, you will get what? Minus 5.
Yes.
So can you see the second bracket looks exactly like the first one? So because
Yes,
they
sir.
look exactly alike, I can simply factorize them again. I can factorize them to look like this. 2x minus 5 is common, leaving me with x and minus 2 in the next bracket. X minus 2. So here we go. Sorry. All this is equal to what? 0. So that
Mhm.
means 2x, if we continue the culture of equals to 0, equals 0, or of course you can tell what distance on answer is by just looking at it. X minus 2 equals 0. Okay?
Okay, sir.
So what next? We'll now take 2x on this side and take minus 5 to the other side, which will make it 0 plus 5, which is 5. And then x will be equal to what? 5 over 2. And that is where that guy ends. While on the right hand side, the right hand side ended even for the left hand side. I have that x is equal to what? Add 2 to both sides, so x is equal to 2. So that's the solution now. So the three solutions are, can start picking it from here. This, this, and this. All right. Did you get that?
Yes, sir.
Was a long one, Abby, but that's it. If you know what you are doing, you can be confident that if you just following through. In fact, the first place that I had confidence that of course, that we were doing the right thing was when the remainder came to zero, because they had told us from the question that 2x plus 3 is a factor of, the guy under the long division time. Okay, so once that one worked out, I knew the others would work out. The only place that was giving me a bit of concern was the quadratic equation, the 2x squared. I was just thinking, will we have to now use almighty formula for it? But gratefully, it solved itself with the simpler method, and we have our three solutions. Now, I don't know whether you noticed something. Typical quadratic equation graph, because the highest power is x squared, only two solutions can come out for that kind of graph. Okay, and when you draw a graph on x, against x axis, you can expect only two solutions. The graph will cut the x axis in two places. But if you see this graph that has 4x cubed, if you
Yes,
draw
sir.
if you actually try drawing it, but I don't think anybody will tell you guys to draw this. But if you could draw it, you will see that the graph will cut x axis in three places. Now what we just did now was we were finding those three places without actually drawing the graph. That's what we just did. We discovered the three places without actually drawing the graph. And the three places on x axis are minus 1.5, that's for 3 over 2. uh, uh, 5 over 2 is 2.5, and then x is 2. So you see that kind of graph is all those sinusoidal graphs that look like, that go up, they will cover up first, then they will come down, and then they will go up again. Okay, so those are the kind of graphs that this thing that has x cubes usually comes up with. Okay, so you got any questions?
No, sir.
All right. Now I don't know if they really expected you guys. Anyway, the space looks much. You can if you actually write well, I'm sure all your working can fit into that box of small small squares, and then you can now put your answer at the bottom. Okay, okay. So the next one says what? Below is a pair of simultaneous. Some people call it simultaneous, but I think it's okay to say simultaneous. Simultaneous equations in x and y, where n is an element of real number, is a constant. It now says one of the solutions to this pair of equations is on the y-axis. Hmm. It now says use this information to find the value of n. Hmm. Okay. One of the solutions to this pair of equations is on the y-axis. Try to decode what these guys are up to. Well, hmm. Okay. Hmm. On the y-axis. we'll read the way forward with this one. 2x minus y equals 7. Hmm. Okay, if they say it's a simultaneous equation, then that means both of them are true at the same time. So I'm thinking what I might do is to use substitution method and start working my way through. Let's see. Let me write down the two equations first. Simultaneous equations, 2x minus y two x minus y equals 7. And then um, x squared plus y plus 2y squared. Okay, plus y plus 2y squared is equal to n. All right. So let's see other information. They said one of the solutions to this pair of equations is on the y-axis. Now, typically, um, when they say this kind of thing, one of the solutions to this pair of equations is on the y-axis. It's simply implying that it cuts the y-axis. Okay, and when a graph cuts the y-axis at a point, it means that everywhere on the y-axis x is zero. Okay, everywhere on the y-axis x is zero. Are you aware of that fact?
No, sir. Bro, we've, we haven't done this, sir.
Oh, okay, okay, okay. Well, fine. The information you can use. So everywhere, in fact, it happens vice versa. Everywhere on the y-axis, x is zero, and everywhere on the x-axis, y is zero. Okay, and maybe that's the ground on which you solve quadratic equation. All right. So if you want to solve a quadratic equation and the quadratic equation cuts the x-axis at 2 points, that's exactly what you're implying, that the quadratic equation is equal to zero at those points that it cuts the x-axis. Remember, the quadratic equation is given by y, usually given by y equals something x squared plus something plus or minus something. Okay, so the concept is that everywhere on the x-axis, that equation is equal to what? Zero. Why? Because that equation is equal to y. So that's just the whole idea. But don't worry, when it uh maybe by the time you guys go fully into understanding graphs and x-axis and y-axis, you appreciate what I just said more. But just understand what I just said now, that everywhere along y-axis, x is 0. And everywhere along x-axis, y is 0. So because they told us this information, one of the solutions to this pair of equations is on the y-axis. What that means is that x will be 0 for that particular solution. So working with that information that they gave us in bold, it means eh, anywhere you see x, for us to find that solution, anywhere you see x, what are you going to put? 0.
0.
Okay, now let's do that. Let's try that and let's see what will happen. So for the first one, I have 2 times 0 minus y equals 7. Okay, and so of course 2 times 0 is 0, isn't it? And so that leaves us with minus y, 0 minus y, which is minus y, equals 7. And for you to have y, you have to divide both sides by minus 1. So that y will be equal to what? Minus 7. So now, you can now take this minus 7, and I'm sure you can think of where I'm going to plug it into. I'm going to put it into the second equation, which, of course, we already know the x is what? 0 squared. Um, the y is minus 7. So I'll just put it in brackets so that when I am when I'm done with my substitution, I can evaluate everything. Then plus 2y, 2y squared is what? 2 times minus 7 squared, okay? 2 times minus 7 squared, okay? And we know that minus 7 squared is what?
49.
49 plus 49. Don't forget your n, because that's what we want to figure out now. So, so let's see. That will be minus 7, because the plus sign becomes kind of useless in the presence of the minus that is there. 2 times 49 is 98, right?
Yes, sir.
So 98 minus 7 will give you what?
That would be 91.
That would be 91. Therefore, n is equal to what? 91. Okay. So the question now is that all they need? Okay. They said use this information to find the value of n. So yeah, technically that's it. They didn't ask us to find x and y. So we're good. So let's see. This is clear enough.
Yes, sir.
So did you notice that the key to this question was understanding that when they told you this thing, when they told you this information, that one of the solutions to this pair of equations is on the y-axis. They were indirectly telling you that one of them has x equals 0 as its um x coordinate. Okay, so all you now needed to do was plug in 0 anywhere you see x, and then you'll be able to work out your values for y. And then, and did you notice that I started with the simpler equation, the
Yes, sir.
2x y. Then I now walked into the second one, which gave me the value of n. Okay, so just remember of course, you know the meaning of simultaneous at the same time. Two equations that are true at the same time. So you can put in values for them into both equations. Okay, so um, all right. So let's let me see. Okay, I think we was that part of it. I think we solved this one, right? Have we solved it?
Mm, I
Eight
think
raised to power three.
no, we haven't.
Are you sure we not solved this one? That solved this one. Let me
Um,
check. Let me check the date of that. Date. Oh, okay. So I thought that we solved it.
no, it was
Uh,
the other one that has one and two
oh, okay.
alone. It looks the same, but we haven't.
Okay. Okay. All right. It looks okay. So let's solve eight raised to the power of four over three. So this one is what do you call the in this one? I think we have it. So eight whole number four over three equals what? Two whole number. Two sorry, two raised to power five x
X
minus
minus three.
and then divided by square root of two. Okay. So um thank God everything seems to be a party for two because what do you call it? Eight is a power of two. How do I know? Two raised to power three is eight. So I can work with that information and start from the left hand side. I can just put two raised to the power of three in place of eight and then still write my four over three there as the power there. Because I'm about to apply some laws of indices. And then on this other side, okay, I'm not going to move too fast with this, even though I could have chosen to do so. But let's just see how everything will solve itself out. Okay, 5x minus 6. Okay. Uh, and if you remember that this thing I showed you, or that will work, uh, square root of 2 is the same thing as 2 raised to power half, right?
Yes, sir.
All right. So now we're armed with this. Let's remind ourselves of some things. Number one, when you have a base, something like x raised to the power of a, and all that is raised to the power of b, indices tells us that we are free to do what? Just multiply the powers. So it will be x raised to the power of what? A, b. Okay, that's the first law we're going to apply. The second law we're going to apply is that x raised to the power of a, um, my a is looking like a cube. Okay, so x raised to the power of a, if you have x raised to the power of a divided by another b which looks exactly like the guy on top, x raised to the power of b, that it is equal to x raised to the power of a minus b. So this one is for, I'm sure you can get what is happening on the right hand side. So, um, so let's deal with the left hand side. The left hand side will now look like this: 2 raised to the power of 3 times 4 over 3. 3 times, I'm trying my best to write that thing small so it doesn't mess things up for me. Um, of course, you can see that the 3 will cancel itself, leaving me with 4, 2 raised to the power of 4 on that left hand side. And then on the right hand side, I apply this law of indices for division, where the bases are the same. It's going to be giving me 5x minus 3 minus half. That will come out well. Minus 3 minus half. Okay.
Okay,
Okay.
sir.
So it looks okay, Abby. You understand it up to this point.
Yes, sir.
Excellent. So that means I'm going to have 2 raised to the power of 4 equals. Now, is there any like term we can do here? We can collect like terms, right? Minus 3 minus half is the same thing as minus 3 and half. Do you agree with me?
Yeah.
And minus 3 and half is what over what? Um, 7 over 2.
Yes.
So I don't want us to go and start doing all that LCS. Well, I know that for some people that would be the right way to teach them, but I think you can handle it. You understand that um, when you have minus something, it's as good as adding it, but in the negative direction. So that will leave me with minus 7 over 2. So that this is what I have now. Now, you know that popular this thing, that when the bases are the same, based on the principle of what? Same basis. Whenever the bases are the same, eh,
You
and there's
just,
an
yeah.
equal sign, the powers must be the same. Okay? And
Okay.
again, I don't usually like it when people say people divide both sides by. We're not dividing both sides by anything. It's on the principle of same basis that we're concluding this, that the powers must be the same. Same base, same power. So we can now solve for x and find our way to the solution. Can collect like terms, right?
Yes,
We
sir.
take this minus 7 over 2 to the left side. That will leave us with 4. Now, this is what I usually like do. I can that 7 over 2, right? I can take it back to minus 3 and a half if you want. Okay, no, no, no. I mean, let's just leave it at minus 7 over 2. Okay. And all this is equal. Sorry, that's not where I should be putting my equal to. All this is equal to what? 5x. Am I even doing it like this? I just realized something I should have done. Okay, so I don't know if it was you I was telling this thing, but anytime you have a fraction, right, you have something in the denominator, and
You
to
use
make
it
things,
to multiply.
thank you very much, you multiply through by that guy that's under. And peradventure, if you had something like this over 3, then you'll be multiplying all of them by the LCM of 2 and 3. Okay, but in this case, we just have two, so it's fine. We'll multiply all through by two. So that's going to be 4 times 2, multiply all the terms by 2, and this one will become 10x, and that guy will be what? Just 7, because it's
Yeah,
minus
two
7
cancel
over,
two.
yeah, it's 2 cancels 2. So what we're left with, which makes it easier for us, is 8 equals, in fact, maybe we should just add the 7 and so on. The everything equals to before I realize this. So I just add the 7 at once and equal that to, equate that to 10x. Okay. So 8 plus 7 is 15, right?
Yes.
That will leave us with 15 equals 10x. So that x will be equal to 15 over 10, which is what?
5x times by 15.
Yeah. We're dividing both sides by 10, isn't it?
Yes.
Okay. So on this side, we have 15 over 10. So what would 15 over 10 be? Okay, so right? Anytime you divide a number by 10, 100,
1.5.
exactly, just move the decimal point one place to the left. So it's 1.5. So there you go. So x is equal to 1.5. So yeah, that's the answer. 1.5, 1.5. Anyone that fits you best can fly. Okay, so did you get that?
Yes, sir.
All right. Okay, I am. Okay. So, okay, this question looks more like that one that we did last time, right? Where it was asking us uh, how many years will it take for the population to reach 16,000?
Yes. Sir.
Okay,
Yeah, it's just the same thing, but
20,000. I think that one was 20,000. Yeah. So what do you say? What do you say you would do in this case? Log with them, right?
yes, sir.
Okay. Is this something you think you can do?
No, I can't.
Oh, okay. All right. So. Um, the principle is very much like similar to this one, but okay, let's just do it. Um, Bacteria population grows according to that model. Uh, so if you have space here, or I should go up, 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 up. I think I should go up. If this guy looks like he's going with this heavy duty. Okay. Oh, excuse me. Uh, okay. children of this guy. I know that this is where the okay, now. Alright, so let me write the equation n c equals what? Was that 500? Yeah, 500 times
Two, two.
the two e over 3. Okay, alright, let me just check it one more time for the confirm. Okay, it says how many hours will it take for the population to reach 16,000? Okay, so first off, um, if we follow through with this, guys, N1, that is after 1 hour, right, means that anywhere we see T, we're substituting the value 1. This will give us uh 500 times 2 raised to the power of 1 over 3. Now, if we are to use logarithm, right, to solve this, okay, then because of the nature of this particular one, we can't use natural logarithm like that previous one that we did. Why? Because E is not involved here. So we'll just use base 10. We'll use base 10 logarithm. That's so we're not using natural logarithm. Okay. Let me bring out my calculator so that you will see what I am doing. The calculator available with you today,
Oh, yes.
and it's working well, right?
Yeah.
Okay. All right. So let me just try and finish it up. We're doing log to base what? To base 10 of what? N1. Don't worry, we'll find what N1 is by finding the anti-log. And this would be equal to log to base 10 of 500. Okay. Um, um, plus, remember, anytime you are doing, when two things are multiplying and you are trying to find the log of them, you will simply be adding their logs together. Log to base of 10 of 2, okay, raised to the power of 1 over 3, and I'm sure you can see by now that the one, something is choking me. Excuse me. So I'm sure you can see that the 1 over 3 will come to the front here, so that you have um log of 500. Okay, maybe I should even start putting in the value. So where's my calculator? 500. Okay, so logarithm, that is 2.6. nine eight. Okay, 6990. 2.6990. 990. Okay. Plus 1/3 times, I think I still remember log 2 is 0.3010. Okay. All right. I hope you have your calculator ready. So we'll punch all this. So can you help me do what is on the right hand side? And I'll advise that you do the 1/3 times 0.3010 first before you now add this. Anyway, you know how to go about it. So tell me, what values do you have?
Mm, I want to put everything. Okay, I should do the 1/3 first and then add it to
Yeah,
with.
know
Okay.
your way around it, where you can do everything at the same time. There's
Oh,
no
okay.
problem. All I know, I just want the answer.
Points. I'm getting 2.7993.
2.799.
Yeah, 3.
Okay, 799. Okay, nice. So can we find, do you know how to
It's
find the,
actually 33333, but I just add to
yeah, I know. Okay, so can you find the anti-log of this? 2.7993.
the ln, yeah.
The 10, you see, you can use second function to access it. The one that says 10 raised to power x, the key that says 10
Okay.
raised to
10 raised to power 2.7.
uh, 790.
That's 629.9411.085.
Okay, point what?
629.9411.
Okay, let's just say point 9, which we can approximate to what? 630. Alright, so now I think we can still do a projection for this. Since they said which year, sorry, how many hours will it take for the population to reach 16,000? Okay, 16,000. So from 500, from 500, it's, okay. So that, maybe that's one way we can do it. I'm thinking of something here. Okay, so, hey, okay, no problem. Let me start something. So I'm thinking that this is one way of doing it. Then we now project. But another thing we can do, let me try this method. Let's try this method. 10,000 equals 500. Okay? And 2 to the power of Okay. Yeah. No problem. No problem. No problem. Um, C over 3. Okay. All right. So, all right. So what I'm thinking now is, right, what value of C will make this whole thing possible? What I'm thinking now is, let's solve it like this. Divide both sides by 500. So that would be 16,000 over 500. Um, equals 2 raised to the power of C over 3. Okay. All right. So, of course, this and this will go, this
32.
and yeah, we'll be left with what? 5 into,
35
huh? Yeah.
in 160, that's 32.
So, this leaves us with 22. I'm just thinking, okay. Oh, nice. Can you see where it's going?
Yes.
Sometimes simplest solutions are just around the corner. So we know that 2 raised to the power of 5 is 32. And so, uh, so the same reason that we did back there for same base, when the bases are the same, right? Is going to work for this one. So let me just write it here. So it will be like a reminder. When the bases are the same, then the powers must be the same. Okay? So the conclusion is therefore 5 is equal to 3 over 3. 5 is equal to 3 over 3. So all we now need to do is to just multiply both sides by 3, isn't it?
Yes, sir.
So therefore, C will be equal to 15. Okay, so it's going to take 15 hours for the population to reach 10,000. Okay, so did you get that?
Okay. So you just bring the T over. Okay.
Mm. So, so you understood why I equated 16,000 to this, right? Because this formula, they told us that this formula gives us the population after a given number of hours. But it's just that we do not know how many hours to work for 10,000. So, like, you know, equate it first, then you now look for a way to find T. And so, yeah, I think this is pretty much it. Okay, so I think I'll do it like I did that other time. I'll send you the file over WhatsApp.
Okay, sir.
All right. Okay. Um, let me see. I think that. Okay, so this one, that's the solution to it. All right, so I think that's about it. I don't, I don't see any other one that is not done, but yeah, okay. So, are you guys done with functions now in class?
No, we're still
Okay,
doing it.
okay, types of functions, I guess. Okay, and the concepts that you are being introduced to, you understand them very well, right?
Yeah, it's just this drawing stuff. But it's fine, I'll just go right.
Okay. What kind of drawing are you guys?
What what is she even call it? Is it vertex to drawing die? Honestly, I don't even no one understood it. It was just like she's gonna give us a draft, a graph, and then she just say we should plot like any
Mm-hmm.
random number,
Mm.
and then you should just construct lines on it.
Okay. What was today the first time to introduce this?
Yes, sir.
Okay. Okay. So there is a likelihood that she will still throw more light on it.
Yes, sir.
Okay. All right. Okay. Let's see. Do you have I okay, so it's till next week again you have your next maths class, have you?
I don't have school next week.
Oh, one of the weeks you said. Next week is like midterm, right?
Yes, sir.
Mm. Okay. So is there any possibility of you engaging with the teacher
Yeah, I will
before
just check I'll just watch a video of the drawing to understand it more.
okay.
Yeah.
Okay. So, because as you are trying to explain it, I'm thinking about it if it's something I can easily figure out myself, but it's not clicking yet. Maybe if I have more information about what it is, I would probably look it up myself. So maybe it won't hurt if you share the YouTube video link with me. I'll take a look myself and see what it's all about. If it's something I can, you know, if it's
Mhm.
something I already know and
Okay, sir.
can explain it maybe by Saturday. Yeah,
Oh yeah,
possibly.
Saturday I will not be. I don't like what
Are you
time.
taking us?
What time
Hmm.
do you want us to do the lesson?
Hmm. Okay. The usual time that I think last time we did it around, was it 11 your time?
No, 10. Wait. Oh yeah, it was 11.
It was 11 your time. Okay. So let me see. Um.
I think it was 10. Let me
Okay.
check the.
So the time. Okay. 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 Yeah. So it was 10 your time, 11 my own time. Okay. So
Yeah.
uh 9 to 11. I know I've been engaged from 9 to 11. Okay. So 12 o'clock, right? 12 o'clock my own time. That's 12 noon. That'll be 11 a.m. your time. Would that be
Oh
good with
yeah,
you?
11 to 1.
Mm-hmm.
Okay. I will just let you. I don't know what time I'm going. because
Yeah.
I'm going with family and friends. So
Yeah. Okay.
I will just conclude the time with them today or tomorrow, and then I'll let you know.
Okay, that's good. All right, no problem. Be looking forward to your message.
Okay, sir.
All right. So do enjoy the rest of your evening.
Thank you, sir.
Okay.